Alright, hello everyone, welcome back. So let's talk about the final exam. Today's lecture is very easy for both you and me, and I'm also very relaxed. Probably for you it's a different story and you'll be very busy right now. But it's okay, after the midterm exams, you can have time to relax yourself during the spring break. So here's our outline for today's talk. In the very beginning, we'll talk about the final exam for you and what are the problems and also some basic information. Then we can go over the topics which we have covered for this course. And we also have something to say for this course for you as well. And we also have some other suggestions for you at the same time after you take this course. Okay, so let's talk about final exam. We will have the final exam in the next week on Friday, March the 18th. And we will do the exam as take-home exam, and we will release a question by the midnight of Thursday. Then you will have about 24 hours to finish all the question in the exam, then upload your answer to the Canvas system by the midnight of Friday. I assume you will have sufficient time to finish all the questions because you have 24 hours. It's a long time, right? And the venue will be your home, your dorm, or some other place you prefer, and the answer will be uploaded to Canvas system as one PDF document. And the exam will be based on individual work. The discussion will be allowed. At the same time, we also offer no QAs during the exam time, so from the teaching staff. We also talk with the TAs, let them know about this. So if you send me ask questions or with emails, we'll not be able to reply you anymore during this time. So any form of cheating on the exam will be resulting in 0 grade, and we also report your case to the university. At the same time, if you observe anyone cheating for this course, please also let me know, and if I can confirm the cases, then I can also give you some bonus as well. So to prepare for the final exam, I think it's time for you to review what we have learned already for this course. And the exam will be about 25% of your final grade. It's a large portion. The topics covered for the exam will be accumulative, and all materials we teach in class, on the textbooks or reading materials will be covered in the exam. At the same time, it will cover all the materials we teach before the midterm. At the same time, we also cover the material we teach after the midterm as well for the final exam. As to the question format, it will be very similar to the midterm. We will have some true-false questions with brief explanations. Now we show you with some examples. Larger learning rates, we always need to choose faster convergence, and transformers can only handle text data inputs. We also have some short answer questions. What is the advantage of LSTM compared with vanilla recurrent neural nets? We also have some calculation questions with some formulas, and we also have some other more question formats. The total points will be about 100 points, and I believe you should have sufficient time to finish all the questions within 24 hours. As to how to prepare for the exam, and I'd like to suggest you please go over the lecture slides or the lecture videos to make sure you understand the materials very well. At the same time, please also study the textbook or the reading materials, to go over what we have learned already. We have also released the homeworks and quizzes. I think you can work independent on the problems in the homeworks or the quizzes, again, to make sure you can get the correct answers, for the question there. And you can also discuss with the people in class, before the exam, and you can also contact the TAs and me if you have any questions. Do some practice, before the exam, and also work the question out before you look at the solutions. Okay, so these are the basic information for the exam, and let's also go over topics we have covered in this course in this quarter. So I hope you still remember we cover different kinds of topics in this course, starting from the introduction section until the last section on the graph birds. So we divide the topics into 5 main sections, which include deep learning backgrounds, deep learning preliminary knowledge, deep learning for images, as well as deep learning for text, and deep learning for graphs. If you still remember, for the background section, we have several parts. We provide you with introduction about deep learning and the machine learning basics, as well as the optimization algorithms. For the preliminary knowledge for deep learning, we have one section on deep learning basics. It covers the neurons, multi-layer perception, as well as error propagation algorithm. So we also have one section on the autoencoders, this algorithm, right, which is also one of the first models we have been introducing on deep learning in this course. And after that, we'll talk about deep learning application for images. We introduce several important models like CEN, GAN. We also talk about how to apply the models for studying some computer vision problems, which are before the midterm. All the topics before the midterm will be covered in the final exam as well. And after we do the midterm, we have 2 other sections about deep learning for text and graphs. When we apply deep learning for starting text data, and we talk about several important models as well, like recurrent neural nets, LSTM, and GRU, and we further talk about some more advanced models like transformer and BERT. We apply these models to start some natural language processing problems and to learn the embedding vectors for the text data, right? As to deep learning for graphs, we talk about some graph neural nets like GCE and GAT, and we'll discuss some new models like GResNet and GraphBERT, and we try to apply them for start the embedding vectors for the graphs and the network inputs for learning their representations. So for the topics we covered before in the midterm, I'd like to suggest you go over the midterm overview as well. We have provided this kind of overview for these topics already. Then in the following part, we'll be focused on the topics we cover after midterm instead. So again, for all the topics we cover in this course, both before and after midterm will be covered in the final exams. Okay, when we apply deep learning for text, we introduce some important models like recurrent neural nets and LSTM. If you still remember, when we talk about recurrent neural nets, we discuss what is the sequence data we can deal with in the very beginning, right? And we also try to represent the sequence data as well by either use one-hot coding or with index or with embedding vectors provided by some other models. Then we talk about how to build a recurrent neural nets. We discuss the architecture of the recurrent neural nets in this model, and we will provide with different forms or different structures of recurrent neural nets depending on the application we have. After that, we'll talk about a very important problem in learning the recurrent neural nets, which is called gradient vanishing and exploding problems. We mentioned what is the problem we are discussing here and why the problem is so serious for recurrent neural nets. And to address this problem, we propose a new model which is called LSTM, right? I hope you still remember the full name for LSTM. It means the long-term and short-term memory. We discussed what is the architecture for LSTM. It is very complicated. We go over this LSTM model for you step by step. What are the internal architecture and also the components inside the LSTM. We explain why LSTM can address the gradient vanishing and exploding problem potentially. And we further simplify LSTM with a new version which is called GRU, right? Compared with LSTM, GRU is much easier or simpler. It will be much more efficient in learning. At the same time, GRU can also address the gradient vanishing and exploding problems potentially. So after the recurrent neural nets and the LSTM, we'll talk about how to apply them for deal with some natural language processing problems and learning embedding vector for the words. We provide you with a brief history for natural language processing, and then we talk about two other important problems. One is for learning the embedding vectors for the words, and the other one is for generation of text. For the word embedding, we talk about how to compress words into vectors, and we talk about two models. One is called CBOW, and another one is called Skitgram, right? We discussed what are the architecture for CBOW and Skitgram, and what are the difference in the architecture and in the performance. And for the text generation with the recurrent neural nets, we discussed how to train the recurrent neural nets for generation of the text, and you have all the choices in your project as well. So we discussed different choices for the recurrent neural nets for generation of the text. Besides the conventional recurrent neural nets, we also discussed some new versions of RNN, right? Like bidirectional RNN and hierarchical RNN in the talk as well. So you can go over the materials if you forget what are the architecture for these two new versions of recurrent neural nets. Again, by checking the slides. So for building the hierarchical recurrent neural nets, we mentioned an important concept is called attention. We will discuss what is the attention used in building the new version of recurrent neural nets in the talk. So the attention will be used extensively in the next part, which is for transformer and BERT. At this part, in the very beginning, we discussed what is attention used in building the transformers and the BERT. And we will talk about what is the architecture of the transformers and how can we build a transformer. The transformer relies on attention a lot, so we discuss what is the rescaled self-attention used in transformers, and also how the transformer handles the input for learning the embeddings, and how to use the transformer for learning the translations in natural language processing. So based on transformer, we further talk about another model which is called BERT. I hope you still remember. So the BERT is based on transformer and with some pre-trainings. So based on pre-trained transformer, we can further apply them to some other tasks by transfer learning and fine-tuning as well. At the end of this section, we'll discuss some other versions of the BERT and the transformers, and we'll talk about different variants and their potential applications. Right? We'll provide with some examples in the talk. Okay, this is about deep learning for text. Besides the text, we also discuss how to use deep learning for dealing with graph data as well, which is for graph neural nets. So for the graph neural nets, in the very beginning, we discussed what is the difference of when we apply deep learning to images and sequence data compared with graphs. And we provide with the reason why we need to have a graph neural nets, which is very different from other deep learning models. And we talk about the GNN objectives, which is to compress the nodes into the embedding vectors. So we have different versions of GM proposed already. We talk about two of them in the talk. One is called GCN and another one is called GAT. If you still remember, for GCN, it is built based on the SGC operator. By stacking multiple SGC operators on top of each other, then we can have a deep architecture of GCN models. We talk about what is the SGC operator and how it works by aggregating the neighborhood information together for learning the embedding vectors for the nodes, right? And we also discuss how to use the SGC operator to build a GCN model in the talk as well. And to illustrate the GAT model, we discussed what is the potential problem with the GCN model in the information aggregation, which penalizes the neighborhood information by the degrees, right? When we discuss what are the potential problems there. And then we further discuss how GAT model handles this problem in their new architectures. And then at the end, we discuss how to apply the GM models for some application problems, like for node classification, graph classification, and so forth. Right. And after that section, we talk about GM applications for network embedding. We discuss the two main topics about which is focused on the HIA embedding and also for the recommended system learning. In the very beginning, we discussed what is HIA, a heterogeneous information network, which represents a complex graph input, contains multiple types of nodes and also multiple types of edges. We illustrated how to represent HIA and what are the examples of HIA. And then we discussed how to apply the GM models to learn the embedding vectors of the nodes in the HIN. We talk about the extensions of the GM model to HIN, also how to apply the SGC operator to incorporate the multi-type relationships among the nodes in the HIN. At the end, we illustrate how to use the embedding vectors for starting link prediction problem for HINs and based on the GM models. Besides the HIN, we also talk about how to build a recommended system, with graph neural nets. At the very beginning, we talk about what is a recommended system and how to use GM models for building the recommended systems. And at the end, we talk about how to train a recommended system with loss functions. So besides that, we also discuss about some other new advanced models, which is called GResNet and GraphBERT. So we mentioned the SGC operator will have some potential problems in learning. It will potentially lead to the suspend animation problem in learning deep architectures for GCN model, right? And to address this problem, we propose a new version of a model which is called GResNet combined with graph resistant learning. We discuss different terms to be defined for GResNet, and we'll compare the different GResNet architectures and their performance. At the end, we talk about the GraphBERT, this new model. We discuss the overall architecture for the GraphBERT, and it covers several steps, covering the subgraph sampling and all the position embedding and the graph transform-based encoder, representative fusion, and the application components. Right. So we talk about how to sample the subgraphs based on PageRank in order to do the learning of the embeddings, of the initial embeddings based on the position information as well as the raw features. And furthermore, we discuss how to learn the embedding vectors and further apply them to some applications for pre-training and fine-tuning. Okay, so these are the topics we have covered in this course, before and after midterm. So you can go over the lecture again, to make sure you can follow all the parts we discussed in the class. Okay, so about this course, we have talked about different models about deep learning in this course already. So the main focus for this course is to introduce different kinds of model architectures, for you, how these models are built and why we're building this way and how to learn them. And we'll focus more on the model mechanism, the architectures, and also model learning for the optimizations. Now we'll cover what is the model architecture and the major components in the model and their design motivations and how to train the models with the optimizers. At the same time, we didn't talk much about the tricks for deep learning. It seems to be important for you, however, at the same time, it's not that important either. So we didn't mention much about dropout, we didn't mention the batch normalization, we didn't mention much about the initialization, and we didn't mention the data augmentation either, right? So these are all the tricks we can play with deep learning, but we don't plan to cover them in the lectures because they are all the tricks. Okay, we also have some potential improvement for this course. According to the feedback for some of the students, some of them suggest to have a discussion session with the programming part. It's a good suggestion. For the future, if we can have more tier design, then we can do the discussion session as well for this course. In this course, we didn't do that. The main reason is because the department only assigns me with 1/2 tier for the course. I'm not sure if you know this or not. Our department has a very strange, also very weird tier assignment policy. They will assign 1/2 tier for every 33 students enrolled in the course. In other words, if we have more than 33 students, then they will assign me with a half TA. If we have 66, then I will have one full TA for the course. If we have more students, then we'll be assigned with more TAs. Besides strict policy for the TA assignment, at the same time, you also set a very strict number for my class size. Instead of my class size to be 50, then I can at most have one half TA only for the course, right? Okay, so these are the potential improvement I have in my mind for the future. At the same time, I also have some suggestions for you as well. So first of all, please do not upload the homework project exams to the Check website. Right now, the Check is more like an enemy for many of the instructors, and we don't want our students to upload the homework projects exams to the Check website. Also, please do not share the homework project and exam to the students who plan to take this course in the future as well. Some other suggestion for you. We know that the computer science technology changes very fast. What we know today may be outdated tomorrow. Therefore, if you want to stay competitive on the market, in the future, you may have to keep learning in the future as well. At the same time, we may have younger people, with new skills and fresh mind join the market every year. So you may need to have to keep learning to stay competitive in the market. And you may want to learn for the future. I always ask myself the same question when I was at your age. So I have some suggestions for you. First of all, please find your interest in different topics. You can find which kind of direction you like more according to your self-explorations. So finding your personal interest is very important. Then you can learn more, via self-learning in the future. Also, please focus on some things that are hard to learn via self-study after your graduation, since many of you still have the time to prepare for yourself before you join the career, join the market for the future. So I'd like to recommend you can further study something which is hard for you to study via self-learning. Some of you probably want to spend more time to learn some new programming languages. I don't think that is very important for you right now because the programming language is very easy to learn. If you have the programming background already, then it should be very easy for you to learn some new programming languages. You can spend your time to start something harder for you to learn, after your graduation actually. So at the same time, please also keep an eye on the technology development trend. You need to see the trend of the technology for the future. Then you can prepare yourself for the future at the same time. Because we have so many different trends right now. Also, do not get distracted too much by some short-term changes of the technology at the same time. Okay, so these are some suggestions I have in my mind. Okay, one more thing. I think right now you have learned the skills already for deep learning, and with this technology or the knowledge you have in your mind, you can do many things. The next suggestion I have in my mind is please use the technology to do something good. In this page, we show you with a link about horror short movie. I don't plan to share this one in class, and you can watch this one by yourself after class instead. So generally with the technology, we can do many things. Some are good, some are bad. I don't hope anyone in our class will be building a killing machine in the future for any complaints for any government. Okay, so what is next? And we'll have one short advertisement. So besides this course I teach in this quarter, I will have another new course to be teaching in the next quarter, which is the ECS 289G on the advanced deep learning. This one is very different from the ECS 189G we teach here in this course, in this quarter, because the new one will be a similar course to be offered in the next quarter. This one will be offered to the graduate students, in the computer science department, especially for the PhD students. And in this course, we plan to discuss the latest deep learning models proposed in the 2021 in the last year and in this year. We will discuss what are the new deep learning models and their application to text mining, natural language processing, to computer vision, to graph neural nets, recommender systems, and robotics, and so forth. This one is an advanced course for senior students, but at the same time, if you are interested in how to apply deep learning to do research, you may also either take this course or audit this course if you are interested in them. Okay, so that's it for today's lecture. And after the final exam, you can also relax yourself a while and also return your GPU to your PC games. You can enjoy yourself. Okay, so that's it for the course. Thank you a lot for your attention and your time devoted to the course in this quarter. Bye bye.